Hello students, today we are going to learn something about the OSI model. First of all, we should know what is communication architecture. When two people communicate, there should be one common language required between the two. Then only these two people are going to understand each other. So is the case with the computers. If there is no common language between computers, then the data transferred by one computer will not be understood by the other computer. Such rules are made so that the two computers can communicate with each other, and this rule is known as OSI reference. This OSI reference model is given by International Standard Organization, right? The term open denotes the ability of two computer systems which conform to the reference model and associated standards. That means both the systems who want to communicate confirm that they are going to follow the OSI model only. Only then they can communicate data. The OSI reference model is the primary model given, and there are many other models which are being followed on the systems, right? This is the basic model which divides the computers, the information which has passed by computers into 7 different layers, and each layer is having its own work dedicatedly given to the layer, and the work of one layer doesn't affect the work of another layer, or we can say the change which we make in one layer doesn't affect the work of the another layer. These are the 7 layers which you can see on this slide. The layer 1 is the physical layer, 2 is the data link layer, 3 is the network layer, then transport layer, session layer, presentation layer, and layer 7 is the application layer. All these 7 layers are having different functions, right? The lower 4 layers, that is the transport, network, data link, and physical layers, are concerned with the flow of data from end to end through the network. But the upper layers are the application layer, presentation layer, and the session layer are more oriented towards the services of to the application layer, right? And the data is encapsulated in a necessary tool which is known at different level with different name. For example, at the application layer, session layer, and presentation layer, the data is known as data, but as the data transfers to the transport layer, it is known as segment. Then to the network layer, it is known as packet. Then to the data link layer, it is known as frame. And finally, when the data goes to the physical layer to transfer, the data is in the form of binary bits, right? Coming up to the first layer, that is the seventh layer, that is the application layer. We'll be starting with the application layer. The application layer interacts with the application program at the highest level. That is, for example, if a person is working on internet and the person opens uh, gives an address in the address bar as www.google.com, then a page opens that is of Google. That means the page which you are seeing at that very moment is at the application layer. The application layer is supporting that page, so the user is able to see that very page. Now the sixth is the presentation layer. Basically, the presentation layer gives or defines the format in which the data is to be exchanged between the two communicating entities. Communicating entities are the two computer systems. The format in which the data has been exchanged between the two communicating entities. The format could be MPEG, JPG, WAV, MP3 files, XLS, PPTX, There are many formats which we use, right, to transfer data. The basic work of presentation layer is this. And what else a presentation layer does is the encryption and decryption of data is done by the presentation layer. The compression and decompression of data is also the work of the presentation layer. Now to the fifth layer, that is the session layer. The session layer is a very important layer, as the session layer gives a logical request for a connection to be established between a user and an end user's request. For example, when I'm going to type www.google.com on the address bar, then what happens? A Google page opens up, right? So the request has gone to the server of the Google, and then only the page has been opened up. So there is a session which has been created between the sender of the request and the receiver of the request, that is the Google server. And this session is allowing the Google page to be opened up on the computer screen. And for example, you have opened three different Google pages in three different tabs, right? And in first tab, you want information about stocks. You are searching some information about stocks. In second tab, you are searching some information about cars. And in third tab, you are searching some colleges for MBA, right? So every Google page is again connected to the Google server, but every page is accessing different information from the Google server. So this is the work of the session layer, that it has created one session for one page, and it is telling the Google server that which page requires which type of information, because all the request is going to the common server, that is the Google server, but which page is requiring which information is given by the session layer, right? Here the session layer works on IP protocol, which is giving the information about the sender and about the receiver. Till this layer, the information which is accessed is known as data, right? Now moving on to the next layer, that is the transport layer. The transport layer is providing end-to-end delivery of data from source to destination. This layer ensures that the data units are delivered error-free and are delivered in a sequence. There is no loss or duplication of data. This all work is done by the transport layer. The transport layer works with two different protocols, that is the TCP and the UDP. The TCP protocol is known as Transfer Control Protocol, and the UDP protocol is known as User Datagram Protocol. The TCP protocol is generally used for files because it gives or guarantees acknowledgement of the data received, whereas the UDP protocol doesn't give an acknowledgement, or we can say it doesn't give a guarantee of the data which is to be received. It just throws data on the network and data is received, or maybe it may be lost. It doesn't give any guarantee. So UDP protocol is generally used in audios and videos. While we use audios and videos while you are talking on phone or you're watching a video online, then when such kind of files are transferred, UDP protocol is used. There is a flow control in TCP protocol, and it guarantees that the data has been reached. The other work of the transport layer protocol is queuing the data, segmenting the data, sequencing the data, and error detection. These all are the work of transport layer. Till the session layer, the data was in the name of data. Now when the data has entered the transport layer, it will be termed as segments, right? The data is divided into different segments. Now coming up to the next layer, that is the network layer. When the data has been transferred from transport layer to the network layer, the data has been divided into different segments. The segment has added the IP of the sender and the receiver. The segment has added what? The IP address of the sender and the receiver, which is the final destination of that packet to be reached. Now, the major work of the network layer is to send the packet from source to destination IP. The network layer defines the optimum path the packet should follow from source to destination. It gives a logical addressing. It finds and handles all the congestion on the network, and it finds the best way to make the packet reach to the final destination. The network layer also defines how to fragment a packet into smaller packets to accommodate different media, right? For example, a packet has started from your PC. It will go to the nearest switch, then to the router which is having maybe less traffic, then again to the gateway, then what satellite. Every path of the packet has been decided by the network layer till the packet reached to the final destinated PC. So now coming up to the data link layer. The data link layer, the work of the data link layer is again, it breaks down the packet which was at the network layer into small segments known as frames. These frames contains the IP address of the sender and the receiver, plus now at this layer the data link layer adds the MAC address of the sender and the receiver, but not for the final receiver. The MAC address is the machine address, that is the address of the machine from which the packet is started is the sender MAC address, and the address of the machine to which the packet will first reach is the receiver's MAC address. First reach, what I mean is the packet will move from PC to switch. So sender address will be the PC's address, PC's machine address, and the receiver address will be switch MAC address, switch machine address, right? Now once the packet has reached to the switch, now the packet is going to move from switch to the router. So the MAC address will change. The sender's MAC address will be the switch address, and the receiver's MAC address will be the router's address. So this is the work of the data link layer, right? So it supports point to point communication, right? From PC to switch, from switch to router, from router to gateway, or from gateway to maybe satellite, and again to the same path reaching towards the final destination, that is the IP of that system on which the packet has to be received, right? Now coming up to the physical layer. The physical layer is basically the layer at which the data actually transmits, that is in the form of zeros and ones, that is in the digital form. The data actually transmits. Now that zeros and ones are being created because of mechanical changes, electrical changes, uh, changes in the level of voltage that creates the zeros and ones which are to be transferred in the physical media, and that all transmission is controlled by the physical layer, that it keeps a track how much amount of data has to be moved, where it has to be moved, in which direction, at what voltage level, is there any need to amplify the current which has been passing into the wires, the physical wires. where the current has been passed, which actually makes the data to be reached to the final destination. So now we are over with the OSI model, and you must have understood the work of each of the layers which are working to transfer the data finally to the destination. Thank you.